Okay, we're going to get started. So I have the honor to introduce Professor Erik Brynjolfsson, not only a professor, but also an author who's written many books and an inventor. Frankly, I consider Erik to be the leading AI economist thought leader in the world today. At Stanford, he is a professor of the Institute of Human-Centered AI, HAI, and a director of the Digital Economy Lab. Prior to Stanford, he was at MIT for almost 30 years, where he also got his PhD, and I still think of him there. He's written over 200 academic articles. He's one of the most widely cited researchers in the world on the economies of AI. He holds 5 patents. He's the co-founder of a new company, WorkHelix, which helps companies identify opportunities for generative AI. So with that backdrop, please welcome Professor Erik Brynjolfsson to the stage.
Good to see you. I've known Mark for a long time, ever since our MIT days together. I'm glad you're out here on this coast now. I'm enjoying life among the AI natives here. And you didn't mention that you are a kind investor in our company, WorkHelix. And I see some of our other investors here, James Chan, et cetera, and a lot of other friends here. So, we've been looking at how AI has been transforming the economy. It's something I've been very interested in from a long time. I actually taught a course on AI back in 1989, believe it or not, about expert systems. And there's just been so much excitement lately, the past couple of years, a lot of hype, a lot of scary stuff like we heard in the last panel, and a lot of concerns. But I don't want to overshadow the fact that there's just been some really fundamental breakthroughs that even some of the top researchers have been surprised by. So, for instance, Michael Woolridge, one of the top AI researchers at Oxford, wrote a book. I was reading his great book called A Brief History of AI. And on page 18, there's this nice little chart about things that computers can do really well that are solved, arithmetic and some other tasks. And then, at the bottom of the chart, there's some things that are nowhere near solved. We have no idea how to do this. Like, understand a story and answer questions about it. Automated human translation. Look at a photograph and understand what's going on. I was looking at this. Wait a minute. What? Nowhere near solved? This is like what we do on ChatGPT for free, like every morning. So that was. But he wrote the book in 2021, a long, long time ago, So back then, these were nowhere near solved. But it just kind of reminds us, sometimes we take for granted how remarkable the past couple of years have been. And if you talk to top researchers, Demis Hassabis, one of the giants of the field was at Stanford. And we were talking, and he said he didn't realize how well these tools would work, and that even he was surprised. And I think a lot of people were. So we're seeing some very rapid progress. You can quantify. I mean, this chart kind of quantifies it, but you can put numbers to it. One of the projects I'm involved in is called the AI Index at Stanford, and we put out this slim little volume, 520 pages, that's filled with charts like this one, and it just documents some of the different benchmarks that are moving and improving. And it's a free report, so you can download it all. And there's a lot of these sorts of charts. Some of them are on the technical indicators. Some are things on patents and investments and people employed in different things and so forth. But you can see that they're all kind of look similar. They're moving up and to the right, and they're getting at a steeper and steeper pace. The first one there is ImageNet, which was a real breakthrough. Jeff Hinton and his team solving was about 17 million images, I think it was, on that Fei-Fei Li put together on ImageNet. And what really set this whole thing off was introducing deep learning techniques. And they turned out to be really effective. And then as soon as he did that and the team did that, a bunch of other folks applied them to all sorts of other things. And now we're getting better and better at hitting these benchmarks. And we could talk a lot about the technology. I bet you a lot of the people in the room here could talk about the technology. So I'm going to try and leave, I don't know, some 10 minutes at the end for Q&A discussion, because I want to get you guys engaged. But it's not just the technology, it's how it's changing the world. So another project I'm involved with is the National Academies was asked by Congress to put together a report on how AI is changing the future of work, or the implications for the future of work. So we actually started this project back in the summer of 2022, before ChatGPT was released, and we've been slaving away on it. Some of the top economists, AI researchers, business executives, and it literally was just released a few hours ago. So I did a press conference earlier this morning, and this is another free report you can download that describes the economic and work implications of it. And here's one chart from it, just showing that while there's a lot of jobs that are being eliminated, technology has also been creating jobs. And so we're still seeing which new jobs are being created, which jobs are being eliminated. But this is historical data that shows that about 60% of the occupations we have today, I bet you more than 60% of the ones in this auditorium, didn't exist in 1940. So there's a lot of new stuff being created. And right now we are at basically record high employment in the United States for prime age workers and pretty low unemployment. So while there's been a lot of technological change, we still have lots of work that's happening. But that is kind of one of the key questions. People are curious about whether that past trend is going to apply now, and we're seeing some of that. So I'll talk a bit about that, and I'll talk about a roadmap for using the technology in organizations before we get to your questions and comments. So back to Jeff Hinton, he introduced these deep learning techniques. He also, had some thoughts about the implications of the technology he was creating. And he looked at how well they could read medical images and was just blown away. There's papers in Science and Nature of machine learning beating humans at reading medical images. And his advice was just, we got to just stop training radiologists. It's completely obvious that within 5 years, deep learning is going to do that better than radiologists. It might be 10 years, but we already have enough radiologists. So what happened to radiologists? I don't know. Anyone have a hypothesis about what's happened to radiologists since 2016? They still exist, exactly. Not only do they still exist, there's more demand for them than there was back then. So we have not stopped training radiologists. When I talk to my friends at Stanford Medical School, they're saying, we can't get enough. We actually have more demand now than we did before. The number of job postings has more than doubled. And there's all these articles. You go Google, you see a bunch of articles about how are we going to solve this radiology workforce shortage. So that's kind of interesting. What's going on? Anyone have a hypothesis? I'm a business school professor, so I may call on you if you don't raise your hand. Do we have some mics? I think we have some mics, right? How about someone in the hallway here, in the aisle, so we can get the mic to them quickly? Okay, your nice loud voice. Go ahead.
For radiologists, I think main thing is their union.
Here comes your mic behind you. Technology.
I think for radiologists, AMA, until the American Medical Association exists as their union, there will be always a radiologist who needs to.
So there's regulatory barriers. They say,
Exactly.
hey, the machine may be doing it, but it's required. Other hypotheses? How about someone over in this? Here we go. Go ahead.
More demand and more awareness, and
more
technology
demand.
is getting sophisticated.
Yeah, more demand as well. So we could spend a lot of time talking about this because I think there's a good hypothesis, but those are both great, and those are both part of it. Let me start with the more demand one. One of the things that's a little paradoxical, at least to non-economists, is that when something gets more efficient and you can do it at lower cost, sometimes you don't end up spending less on it, you end up spending more on it. So some people call that Javon's paradox, but without giving you PTSD, let me remind you of your economics class where there's a downward sloping demand curve, and so as price falls, quantity increases. And if the demand curve is very steep, see that's a demand curve there, then when the price goes down, the total spending, quantity doesn't change much, so total spending goes down. That's kind of intuitive, that makes sense. But what if the demand curve is very flat? We call that elastic. Then as the price goes down, quantity increases even faster, and you end up spending more. Does that ever happen in the real world? Well, I don't know. How many of you guys have flown on a jet plane lately? And did jets make pilots more productive? And did that mean we didn't need as many pilots? No, it didn't work out that way, did it? How about coding? Is coding more efficient now than it was 20 years ago? Does that mean we don't need as many coders? No, it didn't work out that way. So there's lots of examples where you can make things more productive and more efficient, and that actually increases the demand. And we end up enjoying. We have new things that we wouldn't have afforded them before, but now we're doing. So that's part of it. And the other part, the regulatory part, is also important, that people are, just banned from doing, from being taken out of certain things, and there's a lot of regulatory resistance. Regina Barzilay, one of our colleagues at MIT, she's a great machine learning researcher. Sadly, she got breast cancer. She's okay, but then she decided, we need to do a better job of diagnosing these, and so she improved the techniques for medical imaging so you could recognize breast cancer earlier, and it worked really well. And she was showing it to me, and she said, I've been going to all the hospitals and saying, hey, look, I could bring this in, and we can, eliminate all these radiologists with this medical imaging. And she's saying, but they're not buying it. and so I think that I explained to her that it's not just a matter of going in and telling people that you can get rid of them. You have to maybe work on the organizational and cultural and regulatory side as well. So those are parts of the things as well. And I think that the implications we see for radiologists apply in many other parts of the economy, both the demand side, the regulatory thing, and a number of other things that we write about in the National Academy's report and elsewhere. But I think that the best thing to think about is the way that you can really analyze the nature of work. And it's ultimately not at the level of the occupation. It's going down one level further to the level of task. A job is a bundle of tasks. A radiologist does 27 different tasks. A truck driver does a bunch of different tasks. A professor does a bunch of different tasks. Venture capitalists, software. It's not just one big blob. There's many discrete tasks. And what you can do is take every job in the economy and break it down into these tasks. And then you can score the tasks, not the job, but the tasks by whether Gen AI can help it. Writing the memo, Gen AI can help with that. Lifting the box, Gen AI is not going to do much for that. And if you go through each of the different tasks, you start getting a sense of how it's affecting, not between jobs, but within jobs. Once you've done that, you can multiply each of those tasks by some sort of a weight. Maybe you want to multiply it by how much time the person spends on it, or the wage associated with it. And then you roll it back up to the job again, and you can roll it back up to the whole company as well. And that's something we've done in a series of papers in Science and Nature and American Economic Review and elsewhere. And we also have a company, I'll tell you about that a little bit later, that does that. But once you've done it down at what we call the atomic level of the task, then you start getting a much better understanding. So let's do that. And so this is one of the papers that does that, where we did it for about 18,000 different tasks. So let's do that for radiologists. Like I mentioned before, there are 27 tasks that the Bureau of Labor Statistics says that radiologists do. Here's the first 7 of those 27 tasks. And one of them, the one in red there, number 4, is interpret images using computer-aided detection and diagnosis systems. So that's a really important task, and machines have been able to do that much better, and that's great. There's others, though, like administer sedation. I'm not sure I want a machine coming in and administering sedation to me with no human in the loop. And you go through a lot of the other ones, you realize, we really want to keep a human involved in those. A human's better at that, or a human needs to be there for safety or other reasons. And what we see in radiologists is what we see in every other occupation. Yes, there are some places where machine learning or generative AI can help, but there are others where you really want a human involved. We did not find a single occupation, not one, where AI just ran the table and was able to do every single task. In each case, there were some tasks that you really needed a human for. And now you're beginning to see that, okay, wait a minute, so machine learning isn't necessarily going to replace entire occupations. It's going to replace parts of it. So it's not going to be mass job destruction. It's going to be mass job reorganization, mass restructuring as we move around different parts and reorganize. Maybe we create new bundles of tasks organized in different ways. And that's a very different phenomenon. In fact, I think that the coming decade is going to be the greatest business transformation in the history of Earth as we start rolling this through, and we're just in the early stages of that. You can look at the tasks that GPT and related technologies are affecting. My colleague Daniel Rock worked with the team at OpenAI, and they had this great paper, GPTs are GPTs. Generative pre-trained transformers are general purpose technologies. GPTs to economists means general purpose technology. And these tasks, if you kind of group them, while every occupation has some different effects. It's not equally balanced. It turns out that some of the more high-wage occupations actually have more of these tasks. So nurses and doctors and lawyers and accountants actually have more of these tasks than carpenters and plumbers and truck drivers do. But all of them have some tasks. So let's dive a little bit deeper in a particular application. So here's a customer service application, a call center or a contact center. And this is a tool, Cresta, that was made available to these folks. And it's basically an LLM assistant. When someone has a question that's like written in the red, it offers a couple of different kinds of answers there, written in white or black down at the bottom. The customer service agent is not replaced by these tools, but in this case, they are being augmented, and they get to choose. And sometimes they go with one of the answers that the LLM suggests, and sometimes they decide to ignore that, or sometimes they modify it and add to it a little bit. This turned out to be a great natural experiment for me as a researcher, and along with Lindsay Raymond and Danielle Lee, who we did this study with, because they rolled it out in a phased way. Some people got access to it, other people did not. Over 5,000 agents, tens of millions of conversations that we checked and recorded, and we saw how well they did. And what we found very quickly, we saw some very striking results. So here's one of them is the average handle time, resolutions per hour, I should say. And what you can see is the blue line is the folks who did not get access to the technology. And they kind of learned how to do things better a little bit over time. The red line is the people who got access to the LLM. And you can see very quickly they started outperforming their colleagues. And within 4 or 5 months, they were doing much better than even the most experienced agents were doing without access to the technology. So that was a very quick and sharp, measurable productivity gain. We also saw similar things when we looked at customer satisfaction, like net promoter scores, or customer sentiment. You could basically look at the number of happy words and the number of angry words, and the customers had a lot more happy words and fewer angry words. You could look at the employees themselves. I was worried, is this creating an electronic sweatshop, and the employees are suffering to the benefit of the customers and the stockholders? No, actually the employees liked it better too, and they had less turnover. They're more likely to stick on the job, and that's important because this is an industry that has a real problem with turnover. I guess the employees probably liked it better when the customers weren't saying those angry words at them so much. So all three groups, stockholders, customers, employees, got rapid gains. And interesting, if you dive in a little bit deeper, you see different groups within each of them benefited differentially. Here we broke it out into 5 quintiles from the lowest skilled agents, the ones who were doing the worst at the beginning of the study, to the best ones. And you see that the biggest gains were actually from the least experienced and lowest skill agents at the beginning. They got up a 30% or so improvement. The most skilled agents, actually there's hardly any noticeable difference at all. If you squint, it actually looks like a bit of a negative effect. Essentially what the system was doing was capturing some of that tacit knowledge from the best agents and making it accessible to the rest. This is something you couldn't do before you had machine learning and LLMs. If somebody tried to write down all that tacit knowledge, well, I just said it was tacit. By definition, you couldn't do that. But the LLM is able to capture it by looking through these millions and millions of conversations, see patterns of what kinds of words work and which ones don't, and convey that even if no human had ever been able to articulate it. And that disproportionately benefited the agents who didn't have that tacit knowledge initially. Finally, we saw a natural kind of division of labor between them. What we saw was that of course, there are some problems that come up more common and others that are less common. Like, it's very common to ask, hey, how do I change my password? I'm locked out. Some obscure tax question might only appear once in the data set. Which ones do you think that the machines did better at, and which ones did they worse at? Well, machines need training data. So if there's no previous example, the machine couldn't help a whole lot. So it didn't do well at that long tail. The humans, we're not great, we're not perfect at that, but we're pretty good at improvising. And so we kind of muddled through answering questions we've never seen before. So that was a place where the humans had the advantage. In the middle and at the top, the machines tended to have an advantage. So let's talk a little bit, and this, by the way, this pattern shows up in lots and lots of different industries, and there's lots of other studies. So what I described to you for call centers, you see in coding and management, writing, diagnosis. So let's look at a roadmap for going forward. So The company that we started, that some of our investors are here, is called WorkHelix, and it basically takes this task-based approach and it scales it up, and it does it for companies at scale. So let me show you a little bit of how that works. After we scan through a company using their HRIS data, we're able to look at not 18,000 tasks like my research did, but now 250,000 tasks, much more fine-grained. We use NLP to understand what are the job categories, what are the tasks that are important, and then we create a series of guidelines and roadmap to where the opportunities are. Where's the money? Where's the easiest low-hanging fruit? So in this case, this company, I blocked out the name of it, the yellow blob there shows that sales managers is a category with very high opportunity score. It's far to the right. It's about 8.5. Also, the head count in this company is pretty high. It's about 6,000. So that's a good place to look. And if you click through and drill down deeper, you see some of the tasks that Gen AI could help with. But there are others. There's software developers. That's one that shows up in a lot of companies. Every company has a unique fingerprint, but you start seeing some patterns when you look at enough of these. General operations managers is one that doesn't have as much of an acceleration opportunity, but there's a lot of them, so maybe you want to help over there. And then you can look at, once you've picked them, you can create a dashboard of what are the KPIs that you want to track and where are they going, which experiments, how far along are you in your journey. So it keeps track of how you're progressing against these metrics. So ultimately, what I'd like to see is us take this amazing technology and work faster to convert it into productivity and performance. For earlier technologies, that often took years, or in some cases even decades. Electricity, it was about 30 years before you saw big productivity gains. But with artificial intelligence and Gen AI, we can compress that quite a bit if you have a roadmap to where the benefits are and if you have a way of tracking the right KPIs. So we're trying to simplify that and automate it and do that at scale, so a lot of companies can harvest these benefits. And as we start this giant business transformation decade, we want to be the business transformation company that speeds up that process tremendously. So if you'd like to read any of the stats and data that I showed you, here are the URLs where you can get access to it. There's a demo at the WorkHelix website for learning more about it. But I want to just stop now. I've tried to save 5 or 7 minutes for Q&A. Thanks very much. I'd like to hear what questions and comments you have. Thank you.
Erik, if I could ask you a quick question.
Sure. Yeah. Go ahead.
So your study, which I found fascinating, basically says that the least skilled get the most benefit.
That's right.
Out of the use of LLMs, or co-pilots, so to speak, to
Yep.
train them. So are we thinking about all of this wrong? Instead of thinking that LLMs will actually destroy jobs, that LLMs will actually be the ultimate reskilling engine for
They can be.
people?
So I want to be careful about overgeneralizing from my study and a few other studies that find similar patterns, but it's very striking how different it was, because I did a lot of studies on earlier technologies, and we saw the exact opposite. The previous wave of IT tended to be what we economists call skill-biased technical change, and they would help college-educated folks, and they would hurt people without as much education, and that led to polarization and growing inequality. This one seems to be going the other way around, at least in a few of the examples we saw, and so it's in these cases, it kind of compressed the differences and helped the less skilled workers create more value and ultimately get higher wages.
Maybe it's just a matter of getting used to the idea of having even more careers in your lifetime.
That's also true. Yeah, in terms of the skilling, by the way, another interesting result I didn't mention, this system, like all big IT systems, occasionally the system would crash, Bad news for the users, great news for me as an economist. I was like, okay, this is another natural, I love natural experiments. Some people had to now answer questions without getting access to it. And I was worried, has this become a crutch? Like when I have the GPS, I no longer remember how to go to the grocery store. Just the opposite. It turned out that when the system went down, the people who had been working with it continued to be better at answering questions. Not as good as when they had the system, of course, but they outperformed their colleagues. They had internalized some of these tips. So it had become a teaching tool as well as an assistant tool. And that was an encouraging pattern. So other question, I guess we'll go over here. Yeah.
Quick question. I've read reports that take a global perspective and say that the impact on GDP will be much bigger in developing countries than in developed countries. I'd love your perspective on that.
I don't know. I mean, I think actually probably I would go the other way around. What report was that?
I actually don't remember.
Okay. I think that, you know, I'm actually a little bit worried, and it's still early. So yet another committee. I'm on two committees. I'm on the World Economic Forum Future of Jobs Committee. And we have another report coming out that's more focused on developing and middle-income countries and some of the things that are happening there. And a big concern of ours, or a concern of mine, I won't speak for everyone else on the committee, is that this could actually really hurt people in places like India and the Philippines that have a lot of these kinds of jobs. And even though it's augmenting some of them, it's also inevitably going to replace some chunk of them, and the technology's advancing. Also in manufacturing, we're having more and more automation, and that used to be the ladder for low-wage countries to be able to have, you know, maybe they weren't as productive as workers in America or Germany or Japan, but they had lower wages, and so that made certain kinds of manufacturing cost-effective there. But if there's no labor, then low labor cost doesn't give them an advantage. So I'm actually a little bit more worried the other direction, that this could lead to some, you know, pulling apart. And even within the United States, you're seeing a little bit of that right now. That you know, that the Bay Area and other countries, other parts of the country, are actually becoming relatively richer, in part because of these technologies, and it's harder for other parts of the country to keep up. So back over here, I think.
Yeah, I have a question. I'd like to get your take on how you think it's going to impact the motivation and the analytical skill development and deductive reasoning of, you know, say our young people now, and then maybe also touch upon how you think this is going to impact each generation, Gen Z, X, etc.
I think we are in uncharted territory. You know, I wrote a book called Second Machine Age in 2014, Ancient History. And like a lot of people, I sort of believed, and which was probably true at the time, which was true at the time, that machines weren't very good at persuasion and the, you know, the emotional side of things. Humans had a relative advantage in that, and machines were good at sort of more quantitative things. We heard in the last panel that result from Joaquin from OpenAI that these systems can be more persuasive, and that could be happening, you know, in experiments, but also, you know, whether it's you know, TikTok or social media or Replica and some of the AI bots, you know, people are increasingly interacting with bots in their own little bubble with a bunch of AI agents talking to them, and it's almost an unfair fight because, you know, they may have billions of dollars of training behind them, and they've read every book about persuasion and everything else, and then this poor, you know, teenage boy or girl is like trying to make sense of the world. That's a spooky outcome, and right now the average American spends about 8.5 hours per day looking at screens of different sizes, you know, TVs, computers, etc. So we're already getting a majority of our interaction digitally, and I don't have the data in front of me, but I'm pretty sure that young people have been disproportionately exposed to that compared to older people. So that puts us in, like I said, in some uncharted territory where bad actors or even well-intentioned good actors that don't realize that they've misoptimized their machine learning systems could send us into some unfortunate outcomes. Just leave it at that. Maybe one more question, or back over here, right? Yep.
Yeah, I have a question about sort of like how are you measuring the productivity of some of these forces?
Yes.
I mean, is there a leadership principles-based approach there where you're measuring the productivity from maybe you know, like taking ownership or whatnot, right? Like
great question. That's really the multi-trillion-dollar question. I'm blown away by the technology, but the real bottleneck is converting that into value. And you know, even if the technology froze today, we would have a decade of hard work converting into value. And there's a set of leadership principles. I'm a data-driven guy, so my first leadership principle is show me the data. Let's be data-driven. And the good news is we have such better tools for doing that than we did a few years ago. You know, most companies have just a plethora of very detailed data that can now be tapped into. Sadly, most companies aren't really using it. but this is a good segue for me to point out these three guys over here, James Milan, the CEO of WorkHelix, and Yi and Pratik, because what we're trying to do is answer your question, is provide the data, what are the principles, what is the roadmap to doing that, and the more people who I think get on that bandwagon and start being data-driven about identifying the opportunities. It breaks my heart that there are so many CEOs, so many executive teams that are just like throwing money against the wall and saying, hey, Gen AI, do something. Make money. And they haven't really thought about like what is the exact opportunity there? Which are the ones that work? Which ones are the ones that don't work? And how do we have the KPIs? You need like lots of KPIs. You can't just have one that's usually cutting costs. You need to look at the set of what's happening to customer satisfaction, what's happening to workers. And if you have that broader data-driven thing, I am really excited. I think this is, like I said, the biggest business revolution in history, and we can have a roadmap. And if I can help guide people to that, that would be nothing would make me happier.
On the consumer front, is there like what kind of changes do you see for like things like Section 230 and so on to also enforce sort of like that?
Well, there's a lot of policy changes that are in the pipeline. Politics is a little bit beyond my expertise, so I'm just not even going to comment on that. But I will say that there's so much that can be done just within the existing frameworks, and so my advice is the time for experimentation and throwing money against the wall is kind of passing, and now's the time to identify those ROI opportunities and start executing, and hope that your competitors are not doing that, and then you'll be able to race ahead. So I'd be happy to talk to any of you. I think I should give up the stage now, but I'm happy to talk to any of you, individually, or talk to James, Yi, and Pratik, and you can learn a little bit more about what WorkHelix is doing. Thanks very much.